Good day, my scholars. You're welcome to my school channel, and my name is Abiola. Remember, in this channel, we'll be solving a JAMB CBT past question for the subject Physics the year 2013. Do not go anywhere, stay with us, and we'll be right back. Welcome back to my school channel, and in this video segment we are solving questions 30 to 43. So join me as we start with question 30. Capacitors are used in the induction coil to do what? So when we talk about capacitors, we actually charge them to store electrical charge. Okay, so one of the applications of capacitors in induction coil, okay, is to eliminate spark when you put on a particular circuit containing inductance. So that's just to prevent spark or eliminate spark. So the correct option here is option C, prevent electric sparks. Question 31. A cell of EMF 1.5 volts is connected in series with a 1 ohm resistor and a current of 0.3 amperes. Okay, it flows through the resistor. Find the internal resistance of the cell. So we can use the formula EMF E equals, talking about the current into brackets, external resistance plus the internal resistance. So this is what we are looking for. All we need to do is to slot in the values provided, then we derive our answer. So we are given the EMF as 1.5 volts. So we have 1.5 equals the current that we are supplied with is 0.3. Then for the external resistance from the question, we have 1 ohms. So that is 1 plus the internal resistance we have to find. Okay, what do? We divide both sides by this. Now looking at this is 1.5. It also means 3 over 2. Okay, then we are dividing both sides by this. This is 0.3. It means 3 over 10. So that means 3 over 2 divided by 3 over 10, right, equals 1 plus R, isn't it? So let's make do with this. So we have 3 over 2 times 10 over 3. Okay, this actually it comes from 15 over 10. If you look at this, 1.5, remember when we are converting, that makes 15 over 10. 5 here 3, 5 here 2. So this is what we tap out our derivation from. So let's work around this. We have 2 here 1, 2 here 5, 3 here 1, 3 here 1. So on the left hand side we have 5 equals 1 plus R. So we have to sort out what will be the value of R. What do? We send this one to the other side, it becomes negative. So that means 5 minus 1 equals R. That implies R equals 4, or 4 equals R. So 4 ohms. Let's say if we have the value 4 in the options provided. So we find that in option A. So option A is the correct option. Question 32. Which of the following obeys Ohm's law? Okay, so when we talk about materials that obey the Ohm's law, okay, or the ohmic law, we talk about metals, we refer to mercury, hydrous, copper sulfate. So referring to materials that do not obey Ohm's law, we have transistors, we talk about diodes, okay, we talk about rectifiers, we talk about neon gases, we talk about H2SO4. So the correct option here is option B for metals. Metals obey Ohm's law. Number 33. A house has 10 40 watts and 500 watt bulbs. How much will it cost the owner of the house to keep them lit for 10 hours? Okay, if the cost of a unit is 5N. So before we move away from the screen, we are told we have 10 of 40 watt, that is 10 times 40, that is 400 watts. The other bulb, we have 5 of 100 watt, that is 5 times 100, making 500 watts. So from here we have 400, from here we have 500. So 400 plus 500 makes 900 watts. So we have 900 watts to be lit for 10 hours. So we just have to bring this energy to kilowatt hour. So we are having our value as 900. To convert to kilowatts, to be divided by 1000, then the hour That is 10. We are told 10 hours. Okay, so 0 strikes out 0, 0 strikes out 0. Okay, we should have 30 here. This is 1000, please. Okay, so 0 strikes out 0. So 9 times 1, 9. Divided by 1, we have 9. Okay, so we are now told that the cost is how much? If the cost of a unit is 5 naira, okay, so that will be 9 times 5, and that makes 45. So this is the cost we are looking at. Let's see if we have 45 provided in the options given us. We can find that in option C, so option C is the correct option. 34. An electric device is rated 2000 watts, okay, so, and we have 250 volts. Calculates the maximum current it can take. So when we are tapping out for power, we know P equals IV, all right, from several derivations put together. So we can simply use this. P equals to IV. So we are asked to find the maximum current. So we are looking for I. So that means I equals P over V. All right, so we have our P as 2000. Then our V, we are told, is 250. Okay, so 0 strikes out 0. Okay, so I know that's 25 year 1, 25 year 8. How do I know that? 5 year 5, of course. 5 year, 5 in 200, that is 40. 5 year 1, 5 in 40, that is 8. So we can see this makes 8 amperes. All right, so let's go back to the screen to pull out 8 amperes in the options provided. We find that in option B, so option B is the correct option. Please do not forget to click on the link provided in the description below. It's going to take you to the Myschool website. There you can get the Myschool mobile app or the Myschool software, right where you can join thousands of Myschoolers enjoying the beauty and the competence that come from practicing with these tools. So join me as we tackle question 35. When a charge moves through an electric circuit in the direction of an electric force. So when you talk about the electric line of force, talk about the electric field, the direction of all of this put together. So we can see that the charge is actually moving along its natural course. Okay, so that tells you that there will be loss in the potential energy or a decrease in potential energy and a gain in kinetic energy. So option C is the correct option. Do not forget to hit the like button. Also click on the subscribe button and always tap on bell notifications so you can get alerts as soon as we upload the next video segment just for you. Number 36. To convert a galvanometer to a voltmeter, what do? We make that connection. Okay, I resistance is connected to it in series. So you connect it to the voltmeter in series. Okay, I resistance in series. Why for galvanometer to ammeter, that will be low resistance is connected, okay, to it in parallel. So for galvanometer to voltmeter, you're talking about high resistance in series. Then for galvanometer to ammeter, you're talking about low resistance to parallel or in parallel to properly put. So the correct option here is option A. High resistance is connected to the galvanometer in series. Question 37. Induced EMFs are best explained using what law? Okay, so we have Ohm's law, we have Faraday's law, we have Coulomb's law, we have Lenz's law. Okay, so when you check out the electromagnetic, the laws of electromagnetic induction, you will see reference to Faraday's law and Lenz's law. Okay, Faraday's law make us to understand that when there is a change in magnetic flux, that is when induced EMF can be introduced. All right, so Lenz's law basically identifies the direction of the induced EMF. So one of the basic things that we are looking for is how come we have induced EMF. This is due to the change in magnetic flux, and that is found in the concept that Faraday presented. So we are giving it all to option B, Faraday's law. Number 38. If a current of 2.5 amperes flows through an electrolyte for 3 hours and 1.8 gram of a substance is deposited. Okay, at first, what is the mass of the substance that will be deposited if a current of 4 amperes flow through it for 4.8 hours? So it is very important that we segment this presentation. Okay, at first we are told a current of 2.5 amperes flows through an electrolyte for 3 hours, okay, and 1.8 gram of a particular substance is deposited. So we are going to use the law of electrolysis, the first law, and that gives us this formula: the mass equals ZIT. Of course, we are going to tap out this constant. We are given the mass deposited as 1.8, right? So we are looking for Z. The amount of amperes for current, we have 2.5. Then the time is 3 hours. So that will be 3 times 60 times 60. 60 seconds make 1 minute, 60 minutes, 1 hour, then we have 3 hours. So we have to divide both sides by this coefficient. So that will be 2.5 times 3 times 3,600. When you multiply this together, the same thing goes here. Okay, so I can make this easier. We know 1.8 means 18 over 10. 2 here 5, 2 here 9. So this means 9 over 5 divides 2.5 means 5 over 2, right? Times 1 over 3 times 1 over 3,600. So let's save time. When we switch signs to times, okay, this one goes up, this comes down. So we are going to have times 2 over 5. All right, so from here we have 2, 1, yeah, that is 1,800. Okay, we have 3 here 1, 3 here 3. Okay, we still have 3 here 1, 3 in this, we have 600. So at the denominator we have 600 times 5, that is 3,000, times 5, that is 1,500. So for Z, we've gotten the value of Z as 1 over 15,000. Okay, so we are just going to impute this in the next statement that we are going to interpret. So you can take your time to go over this clip over and again until you understand the concept at your own pace. So somewhere on the board, we are going to store this value of Z as 1 over 15,000. So we are going to impute it in the next statement. So statement B, we now have what is the mass of the substance that will be deposited if a current of 4 amperes flows through it for 4.8 hours? So we are asked to find mass. We have our Z now as 1 over 15,000. Okay, times the current I supplied, that is 4. Then we are told 4.8 hours. Okay, so we know that 4.8 means 48 over 10. And this is 2 here 5, 2 here 24. So we have 24 over 5 times, remember we have 4.8 hours. So times 60 times 60, okay, over 1 over 1. Okay, so now let's walk around this. Right here we have 5 here 1, 5 here 12. Very well. Of course we have 2 here 2, 2 here 7,500. Okay, so what else can still put through? We should have 5 here 12 as well. 5 in 75, that is 5 in 75, that is 15. Then we have 2 zeros. Okay, what else can we walk around? We can walk around 3. We have 3 here 8, 3 here 500. What else can we walk around? We can still walk around 2 here 1, 2 here 250. Of course, we still have 2 here 4, 2 here 125. So basically I have, for the numerator, we have 4 times 12 times 12 over 125. So let's multiply. 4 times 12, we have 48. 48 times 12. Remember, as much as possible, we are going to do away with calculators. 2 times 8, we have 16. We leave 1. 2 times 4, we have 8. 8 times 1, we have 8. Okay, no, plus 1, rather, that is 9. So 1 times 8, we have 8. 1 times 4, we have 4. So from here, we have 6. 9 plus 8, that is 17. We leave 1, making 5. So for the numerator, we have 576 over 125. Okay, so roughly 4.608. So when we move this to probably the last figure standing after, just one figure standing after the decimal point, okay? So that should give us 4.6. And we are working with mass, so the unit should be in grams. So we are looking at 4.6 grams. So join me as we go back to the screen and see if we can find this value in the options provided. That is found in option C, so option C is the correct option. Question 39. Calculate the energy of the third level of an atom if the ground state energy is minus 24.8 electron volts. Okay, so all you just need to do is to take this value over n square. N represents the energy level you are working at, and that is the third energy level, that is 3. So 3 raised to power 2 makes 9. That will be minus 24.8 over 9. When we do that division, it should be around 2 points. Some values or digits, okay, because we know 9 times 2 is 18, so definitely 2 is standing and every other values come after it. So we can tell confidently that option C is the correct option, not neglecting the minus sign. So we are having minus 2.75 electron volts. Option C is the answer. When you click on the link in the description below, it's going to take you to the Myschool website. There you can ask your questions right now, and our solution providers are waiting to help you out. So join me as I solve question 40. In photo emission, the number of photoelectrons ejected per second depends on what? On the intensity of the radiation. And that is found in option D, so option D is the correct option. Perhaps you have better steps or explanations in tackling any of the questions we have solved so far. Please, we'd like to know you need to do. Use the comment section below, indicate the question number and the solutions you'd like to share. Question 41. The particle nature of light is demonstrated by what? The photoelectric effect. Okay, so the electrons emitted in the course of light falling on the metal surface, they are referred to as photoelectrons. So this shows us the particle nature of light. So the correct option is option A, photoelectric effect. 42. The energy of a photon having a wavelength of 10 raised to the power minus 10 meters is what? Okay, this is our Planck's constant and this is the speed of light. So we just walk around this formula. The energy, we know that a photon has energy, of course, so that energy will give us, this is your Planck constant and the speed of light. So we have this constant given from the question provided as 6.63 times 10 raised to the power minus 34, right? Multiply the speed of light, okay? 3 times 10 raised to the power 8 from the question. Then we have all over the wavelength. The wavelength is given as 10 raised to the power minus 10. So at first, when we multiply this, so let's do the multiplication. 6.63 times 3, okay? 3 times 3, we have 9. 3 times 6, we have 18. We leave to 1. 3 times 6, 18 plus 1, we have 19. So we have 19.89. Roughly, we can bring this to 20. So at the numerator, I have 20 times 10 raised to the power minus 34, right? Then we have 10 raised to the power 8. Times will turn to plus 8. Then this is underneath. When it comes up, it will become minus. The divide here means minus into brackets minus 10. So minus times minus, that is plus. So I should have 20 times 10 raised to the power minus 34 plus 8 plus 10. 10 plus 8, that is 18. Minus 34 plus 18, that should give us minus 16. So I have 20 times 10 raised to the power minus 16. So if I want to move this to 2, all right? This 20 will affect 16. This 20 will reduce this to 15. If you use your standard form properly, so that will be 2.0 times 10 raised to power minus 16. Okay, just to elaborate, we would have this means 2 times 10 raised to power 10. 2 times 10 raised to power 1, okay, times 10 raised to power minus 16. So 1 minus 16, that is minus 15. So that is how we derive this. So we should have 2.0 times 10 raised to the power minus 15. Join me as we move back to the screen and see if we can confirm this option or this value in the options provided. So where do we see that? We find that in option A. So option A is the correct option. Question 43. The bond between silicon and germanium is what? Okay, 32. This is 14. Okay, so when you check their configuration, you realize that they both have 4 valence electrons. And when you refer to covalent bonding or covalent type of bond, okay, you will see that both elements, okay, or both atoms, they contribute so that both of them can attain the octet rule. Okay, so in this particular case, we see that silicon needs 4 to obey that. Germanium as well needs 4. So they are going to combine together, and both of them will both share their 4 together to become 8 in the atomos shell, of course. So the correct option will be option B for covalent bond. Right there, we've come to the end of this video segment, but there are definitely more interesting and interactive content to come. All you need to do is to hit that like button, also click on the subscribe button, and always tap on bell notification so you can get alerts immediately we upload the next video segment all for you.